Good morning students, I am your Abhijit sir, and in this class we will learn factorization, that is how to factorize a polynomial. This is from chapter 4 of your maths book. See, we have some steps to follow for the factorization. There are actually 9 steps I have mentioned here. You should write all the steps starting from the first one. Find out the common factor. See, as all you can see, find out the common factor of two or more terms. Here terms means actually the individual terms which makes a polynomial. Now the second step is to take out the common factors from a polynomial outside the bracket. In this way there are several steps, total 9 number of steps, and in this class we will complete up to 7 steps. So it is better that if you write all the steps, because later I will mention those steps as the 9 levels to solve the math, solve the factorization. Now come to the first step, that is uh, to find out the common factor of two or more terms. See, we start from here. This is the first step, how to find out the common factor of factors of two or more terms. Here I have mentioned three terms: 48x square y square, 12xyz, and 8x square y square z square. See, first, for this 48, I have factorized 48 as 4 into 12 into x into y into x into y, as you all can see. Now this is the proper factorization of this term only. Now come to the second term, 12xyz, and the factorization is a 4 into 3 into x into y into z. So for those two, what you found, two common factors, that is 4 are common, and this xy and xy is common. Now see the third term, we have 8xyz, x square y square z square, and in the same way we can factorize this term also, 4 into 2 into x into y into x into y into z into z, that is z square. So now for those three terms we have some common factors, two common factors actually. 4 are the common factors which present in all these three terms after factorization, that we found after factorization, and xy is also present on all those three terms as a factor. So 4 into xy now become the common factor of all those three terms. So for those three terms we have the common factor xy, 4xy actually. So this is the explanation for the first step, which is quite easier, how to find out the factors of two or more terms. See, we have one more example here, this one, a square. See, a square and 2ab. From a square we can take a, and from 2ab we can take a as a common factor. So for those two terms, a square and ab, we have the common factor a. Now come to the next step, which is considered as next level. You can see, you can understand. See, we have the second step as take out the common factor from a polynomial. As in the first step I have taken one example with three terms, 48x square y square, 12xyz, and 8x square y square z square. So the same term I have mentioned here as a polynomial p1, 48x square y square, 8 minus 8x square y square z square, and plus 12xyz. So as you all know, in the previous example 4xy become the common factor of all those three terms. So now we can take out the common factor 4xy as a common factor outside the bracket, and now what we left inside the bracket, see, we go to the first example again. When 4 is taken common and xy is taken common, what left? 12 and xy is left. See, 4xy is taken common, 4xy is taken common, then 2, 12, and this xy is left. For the second term, that is here 4 is taken common and xy is taken common, so 3z is left. So now come to this, here we have to take out 4xy is common, so 12xy left inside the bracket for this 48 x square y square. Now for this term 4xy is taken common, so what left? 2xy z square. From this we get 3z when 4xy is taken out common. So this is the complete factorization of this polynomial p1. Now we have one more polynomial as an example. Here it is p2 and 3m square minus 9. You all know from those two terms 3 is taken out as a common factor, because here 3 is as a factor and here in 9 3 is also as a factor. So when 3 is taken out common, m square left and minus 3 left inside the bracket. So this is the complete factorization of this polynomial p2. So second step is over. This is the factorization. Now come to the third step. Take out minus 1 as a common factor. See the examples we have b minus a. Actually the common thing is that a minus b. Here we have b minus a. So minus, if minus is taken out common, minus 1 is taken out common from those two terms, then what left? See here, when minus is taken out common, minus 1, then the signs of the terms, sign changed. See, the a is initially with a minus sign. When minus 1 is taken common, a become plus. This b is with a plus sign here, and when minus 1 is taken common, this b become minus b. So when minus 1 taken out common, the signs of the terms changed. Now for this b minus a, we have minus 1 whole into a minus b. This one can be written as minus whole a minus b, that is minus means minus 1. So in this way we can take out the minus sign as common factor. Now we have one more example. See this example. We have 3p square q minus 4 pq square plus pqr, and just see what is the common factor that can be taken out from this. See, pq is present here, pq is also present here, pq is also present here. So that means pq can be taken out as a common factor. But as here we considering about taking out minus sign as a common factor, so just we consider that minus, if minus is also taken out common with pq, so that's why I have taken out here minus pq as a common factor. So as pq is taken out, so what left in the first term? 3p. So 3p left. As minus is also taken out common, so this 3, which is actually initially plus 3p square q. Now after taking out minus as a common factor and pq as a common factor, here we have minus 3p left inside the bracket. See, now from this term 4 minus 4pq square. So as minus is present here and minus is taken out common, so the sign become plus. See, this one you can easily understand. Now this minus sign. Now as pq is taken out common, so what left here? 4q is left. So 4q is left. Now from this term, third term, see, from the third term we have pqr, that is when pq is taken out common, r remains left. But here minus sign is also taken out common, so that means this plus sign of pqr becomes now minus, and as r is left here, so r remains inside the bracket. So minus pq is taken common, and we have inside the bracket minus 3p plus 4q minus r. Now see this example. Here we have all the terms with a minus sign, minus m, minus n and minus r. So these three terms and minus can be taken out from all those three terms, and all the signs of those terms changed. So minus taken out common, so minus into whole m plus n plus r. Okay, so in this way we can take out minus as a common factor, minus 1 or minus. Now go to the next step. We have take out the bracketed terms as a common factor. Now we have, see the first example, x square minus 3x plus 9. So from the first two terms, x square minus 3x. See here x square, that means x can be taken out common. Here is also 3x. So when x is taken out common from the first term, see, from the first term when x is taken out common, x remains left. And when from this 3x, x is taken out common, 3 remains left. Now see the second two terms. We have minus 3x plus 9. Now we are taking out minus 3 as a common factor. So minus 3 as a common factor is taken out and x remains left here for this third term. Now see, when minus 3 is taken out common from this 9. So 9, the factorization of 9 is 3 into 3. So when 3 is taken out common, 3 is left. From 9, when 3 is taken out common, 3 is left. But here minus 3 is taken out common, so this plus sign now become minus sign. I think you all can understand, as minus is taken out common here. See here minus is taken out common, so this plus sign now changed inside the bracket as minus sign. So we have now two terms, actually two bracketed terms, two same kind of bracketed terms. See here x into x minus 3, here minus 3 into x minus 3. Those two terms can be taken out as a common factor because those two are same. So x minus 3 taken out as a common factor, and what is left, x minus 3. And here it is, when x minus 3 is taken out common and x minus 3 is taken out common, what left inside the bracket, this x and this minus 3. So this x minus 3 is left. So this is how we complete the factorization here. Now we have one more example. See, this is 4a square minus 2ab minus 14ab minus 7b square. First consider the first two terms. We have 4a square, so and minus 2ab. So from this 4a square, 2a can be taken out common, and here in the second term 2a can be taken out common. So what left here, from 4a square 2a is left, and from this 2ab b is left when minus 2a is taken out common. Now see once again, 2a is taken out common, what left, 2a inside the bracket and minus b. Why? Because from this 4a, when 4a square, when 2a is taken out common, 2a is left. From this 2ab, 2a is taken out common, so b is left, minus b. So this is for the first two terms. Now see the second two terms. Here we have 14 minus 14 ab square and minus 7ab. This one be plus. See, I expected that most of you found the mistake. If we take here as plus sign before 7b square, then what is the factorization? See, when minus 7b is taken out common, then from this part 7b is taken out common, so 2a is left, and with a plus sign inside the bracket. Here before the 2a there is a plus sign, and here as this one is plus 7b square, so 7b is taken out common with a minus sign, so the sign will change to minus and b left here. So inside the bracket we have 2a minus b. Now it is plus. Okay, now see, we have this bracketed term and this bracketed term, and we can take this bracketed term as a common factor. Now we have 2a minus b whole into here 2a minus 7b. So this is the factorization. So this is what we do when we have to take out the bracketed term as a common factor. Now see, what is the next step? Rearranging the terms. See, we have to rearrange the terms, the individual terms in a polynomial. We have to rearrange those terms and find out the common factor. See, we have the example 5p square 16q minus 8pq minus 10p. See, after the rearrangement of the terms, see what we replace here. Here we have taken 10p. See, this 10p just after 5p square. so we can take 5 and p as common factor. So for those two, see, 5p is taken out common, and here we get p inside the bracket and minus 2. So this is the first part over. Now we have the next two terms, that is 16q and minus 8pq. This is rearranged term. Now from those two terms we can take 8q as a common factor, and what we have, this one, 2 minus p. See, if we rearrange the term in a different way, then we can do this sum a more easier way. See, first see this one. Here we have 8q as a common factor, and this one 2 minus p. So here we have p minus 2, but here we have 2 minus p, so we can take out the minus sign common, that you have gone through in the third step or fourth step. See, so we can take out the minus sign common, and it will become p minus 2. Initially it is 2 minus p, as minus this one is plus, so this one is when plus, and when we will take minus sign as a common, so this plus 2 become minus 2, and this minus p become plus p. So now we have p minus 2 here, and here also p minus 2. So these two bracketed term can be taken out common, so p minus 2, and this is taken out common. So inside the bracket we have 5p minus 8q. So this is the complete factorization. Now if the terms are rearranged in this way, see, when 5p square, 10p is taken just after 5p square, and 8pq is as it is, and 16q is shifted to the last. See, then you can take directly the common terms. 5p is taken common, and inside the bracket p minus 2, and here 8q is taken out common with a minus sign, and it will become p. This one is actually plus, this one is actually plus, so here it will be p minus 2. Okay, clear? So 8p taken common, and here p minus 2, here also p minus 2, so p minus 2 can taken out common. So now go to the next step. Here we have the sixth step, that is to break the bracketed term and then take out the common factors. See, here we have, this is one of the question from your exercise, I guess. Y square minus xy whole into 1 minus x plus minus x cube. So first what we do, we have a bracketed term. This one is the bracketed term, and we can break this bracketed term. See what we have, when 1 is multiplied with xy, we have minus xy, and when this xy is multiplied with minus x, this minus is plus. Okay, I think all you understand here, that this one is a minus sign here, and this one is a minus sign here. So this minus become this plus sign. Okay, so this one become x into x square plus x square y. Now the x cube remains as it is. So the terms are rearranged. That means there is no need to rearrange the terms, already those are arranged. So here we can take common as y. See, y can be taken out common, and this one become y minus x. Now here we can take x square as common factor for those two terms, so this one also become y minus x. Now we have two bracketed terms, same, y minus x and y minus x. That means we can take out y minus x as a common factor, and what we left, y. See, when we take y minus x as a common factor, this y minus x and this y minus x, we have y plus x square. So this is the complete factorization we have. So in this way we first break the bracketed term, then solve for the factorization. Now see, we have one more example of the same step. See, here we have the question ab at whole into x square plus y square minus xy in whole into a square plus b square. So first we have to break the bracketed terms. See, after breaking out the bracketed terms, we have abx square plus aby square minus xya square, as minus is there, so the signs become minus, and this one is xy b square. Now there is a rearrangement required. See what is the rearrangement here? See, here we have the first term a b x square remains as the first term. Now we shift this term as second here. See, this one is shifted here. Now from those two we can take out common as a x. Okay, so a x can be taken out common, and what left? Bx minus ay. So this is for the first two terms. Now see, for the second two terms we have this a b y square here. Okay, and here we have x y b square. So from those two terms we can take by as common factor, and what left? A y. So a y minus here bx, as b and y taken common, so bx is left. So this is for the second two terms. Now we have here, see, again we come to the same conclusion. That means our rearrangement is not so good here. So I think there is no any matter, because we all know how to take out the minus sign common. So here we have bx minus ay, but here we have ay minus bx, just the signs are opposite. So here we can take the minus sign as common, because here we have plus by, so we can take minus sign as common from this bracketed part, and when minus sign is taken out common, this bx become plus and this ay become minus. So as this minus taken out common, so now we have minus by as the common factor and bx minus ay. So bx minus ay is two bracketed terms, same bracketed terms that can be taken out common, and here we have taken out bx minus ay as common factor, and what left? Ax minus by. So this is the complete factorization. So this is how we do for this step. What we have, see, break the bracketed terms and then take out the common factors. Now we have one more example. See, here we have the bracketed terms as square. See, we have pq plus 1 is whole square and this p minus q whole square. So we can use the formula of, you all know, a plus b square and a minus b square equal to what? So we use the same formula here. Here we have break this one as a p square q square plus 2pq, you all can understand, I guess, and plus 1, and this one is p square minus 2pq and plus p square. See, those two terms are same with a plus and with a minus sign, so that means those are cancelled. See, those two are cancelled with a plus and minus sign. Now what left? This one is left. Is there any required rearrangement? Yes, of course. So we rearrange those terms, like suppose we have a p square q square here, and this p square q square remains as the first term, and this, suppose this p square is shifted here. Now for the first two terms, from the first two terms we can take p square as common factor, and what left? Q square plus 1 left. Here we have q square plus 1, so that means q square has a factor 1 always and 1 has a factor 1 always, so 1 can be taken out common here. So 1 taken out common, and this one remains as q square plus 1. Now we have two same terms, q square plus 1, q square plus 1, two bracketed terms can be taken out common, and this one be q square plus 1, and what left? See, when this term and this term taken out common, what left? P square plus 1. Now we can just rewrite the terms, p square plus 1 whole into q square plus 1. So this is the factorization. Now come to the next step. This step is very important, because here we have to introduce a new term. So it requires some sense. That means how we will think about the question. See, here we have a square minus b square. Actually you all know about the formula a square minus b square, but see what we do here. We have a square plus b square, so we introduce two new terms here, plus ab and minus ab. As you can see, those are the two new introduced terms. Why those are introduced? Because see, you can see why those are introduced. But see, if plus ab and minus ab are introduced, then those cancel equal to 0. As here we have a square plus b square plus 0. So actually for this 0 we can write a plus ab and minus ab. Now see, we rearrange the terms like what we have: a square plus ab and minus b square minus ab. What can be taken out common? Here a can be taken out common and a plus b left inside the bracket, and here minus b can be taken out common and a plus b left inside the bracket. So we have two same bracketed terms, a plus b and a plus b. See, a plus b, this one is a plus b and a plus b, so this can be taken out common, and what left? A minus b. So this a square plus b square, which is the initial question, becomes a plus b and into a minus b. So this can be used as a formula. Now see, we have a to the power 4 and b to the power 4. See, we have a to the power 4 and b to the power 4, and for those two we introduce two new terms, that is 2a square b square minus 2a square b square, plus 2a square b square and minus 2a square b square becomes 0. So in the place of 0 we introduce those two terms. Now we rearrange the terms. This one is called completing the square method. This one is also called completing the squaring method. See, why it is completing the squaring method? Because here we see what we do. We take a to the power 4 as a square whole square, b to the power 4 as b square whole square, and this 2a square b square. Now this one is actually a formula of, all you know that this one become a square, that is the first term, and plus b square, that is the second term, and whole square, because 2 a square b square is also present. So this one actually a formula. So that's why I am telling that this is an important step. Here we have to introduce a new term by our sense, how we can uh, represent this as a formula. So here we have what we found here, a square plus b square whole square, and what left here? Minus 2ab is left. So we got a formula here: a to the power 4 plus b to the power 4 is equal to a square plus b square whole square minus 2a square b square. Or suppose if we have the same, that is a to the power 4 plus b to the power 4, we can take like this: a square minus b square whole square plus 2ab. And I think you should try this, how this will come. Now see, we have some questions. We have to factorize a terms given here. See, this is the question: a to the power 4 b to the power 4 minus 7 a square b square. This is a question from your exercise. Now we add and subtract 2a square b square, and I think now you know that why we adding 2a square, why we are adding, in what sense we are adding 2a square b square. You all know that a to the power 4 and b to the power 4 is here, so that's why we are adding 2a square and b square to complete the whole squaring method. See, here we have introduced 2a square plus 2a square, and this one is minus 2a square b square. So for those two actually it is 0. We just introduce this term in order to complete the square. So here we got a formula. See, this one is actually a formula. Now we have, for this we can write a square plus b square whole square, and minus this one becomes, see, 9ab square, and this one is 9ab whole square, 3ab whole square. Now we can use the formula, this one that we here proved: a square minus b square is equal to a plus b and a minus b. So see here, I have introduced here, I have taken here as x square minus y square, so x plus y and x minus y. So this one is a square plus b square whole square, and this one is 3ab whole square. So this one is actually x and this one is actually y. Okay, so as x plus y is there, so this one the complete x term and this one is complete y term. So x plus y, in the place of x plus y I can write a square plus b square plus 3ab, and this one is x minus y. So this one is actually x and this one is y in the place of, just we made the substitution here. So this one is a square plus b square minus 3ab. Okay, so this is how we will factorize. Now see, the next question we have x to the power 4 14x square plus 1. Here we also introduce 2x square. See, we have x to the power 4 and we have 1. So that means this one is x square square. See, x square whole square. So this x to the power 4 can be taken as a first term and 1 as the second term. Now what we introduce here, 2x square, and why we introduce 2x square, in what sense you all know. So now this one becomes a formula. See, this one, this underlined terms become a formula, and for those we can write x plus 1 whole square, and this becomes 16x square. So 16x square means 4x whole square. So now we can write, see, these are the factorization. So now we can solve the exercise up to 4.1, 4.2 and 4.3. See students, these actually those steps are actually the levels of, suppose you can consider levels of game that you achieve. Here if you can easily understand step 1 to 3, then that means you are in the level 3. If you can easily solve up to step 6, then that means you are in level 6. So you decide your level here for this game. This is actually, now you can consider this one as a game. So thank you class, do your exercise maths. Thank you.